Chapter 4, 4.1b is bias sampling techniques. So, using a method that will consistently overestimate or underestimate the value we want to know is called a bias sampling. So, we do not want a bias sampling. We want it to be truthful, we want it to be representative, and we want it to mimic what is actually going on in the population. So that's why we need to look at what causes bias and see what we can do to limit it or lower it. So choosing individuals from the population who are easy to reach results in a convenience sample. So an example would be ask the first 30 students who enter the school library in the morning how much time they spent doing homework last week. So what would be the problem with this sample or with this method? Well, think about this, the students. So you have first 30 students who enter the library in the morning, how much they spent time doing homework. So do you think there's some kind of correlation with if you're going to the library doing homework, you're first to enter? Just think about it. So, students that go to the library first thing in the day are more likely to be studious, more so than the average student. So, this will probably overestimate the population average for all students. So, this convenient sample creates a bias. A voluntary response sample consists of people who choose themselves by responding to a general invitation. So, this would be an example of someone calling you on your phone and saying, "Hey, would you like to answer a couple of survey questions? Would you like to participate in our poll?" How many of y'all say yes? Or how many of y'all hang up? Or maybe put on a funny accent and answer the questions? So, what's the problem with this kind of sampling? It does not represent the whole population because they often attract people who feel strongly about the issue. So, examples would be online polls, call in voting, email surveys, or someone calling you actually on your phone. Or it could be someone with a clipboard standing out in front of a place asking you questions. So these people, most of the people will be like, I don't have time for this. But the people who feel really strongly about a particular issue, they'll be like, yes, I'm going to answer these because I want you to know how I feel. So what can go wrong even if the method is good? So some sampling is done well. So a simple random sample, a stratified, or a cluster, but it can still lead to bias. So undercoverage occurs when some members of the population cannot be chosen in a sample. So under coverage. Okay, so an example would be a survey conducted about increased funding for Medicare by calling randomly selected landlines. So how many of y'all have a landline? I don't have one anymore. Do you know somebody who does? So usually younger people don't have landlines. So this is going to be an overestimate of the number of people who'd be in favor of Medicare funding. Okay, what can go wrong even if the method is good? Well, no response or non-response occurs when an individual chosen for the sample can't be contacted or refuses to participate. So let's say a survey about unemployment was conducted over the phone during the day. So what's wrong with that? So during the day, unemployment, well, people who are employed usually aren't sitting by the phone during the day. People who are employed usually can't answer the phone, but unemployed people might be on the phone, be able to answer the phone. So people who work are less likely to answer the phone or decline to answer questions because they're busy. So this may overestimate the proportion that are unemployed. So here's your AP tip. If you're asked to describe how the design of a study leads to bias, you're expected to do this in two ways. So one, identify the problem with the design, and Explain how the problem would lead to an underestimate or an overestimate. So you need to do both of those things. So what's the problem, and will it overestimate or underestimate? So a common error. Many students lose credit when describing what can go wrong in the sample surveys because they use incorrect terminology. So while it's important for students to understand and use the vocabulary of statistics correctly, they're rarely required to use specific vocabulary in their response. So it's important to just describe it, even if it's not using statistics words. Just describe what the problem is and whether it would make um, the bias, and you don't even have to use the word bias. You just have to describe how it will affect the the, the proportion. Will it will it increase it, or will it be lower than it normally should? Okay, so here's an example. To estimate the proportion of families that oppose budget cuts to an athletic department, principal surveys families as they enter the football stadium on a Friday night. So let's think about the question. Oppose budget cuts to athletic department. Okay. Explain how this plan will result in bias and how the bias will affect the estimated proportion. So, what is the problem with this? Think about the families. The families who are attending the football games, they're going to typically oppose athletic budget cuts because they are really into athletics. The responses to this study, gathered by a convenience sample, because that's what this is, will most likely overestimate the opposition compared to the true opinion of all high school families. Because your goal is always to get what is the true population's opinion. If you're only going to a place where families who are invested in the athletic department, you're going to get an overestimate, as opposed to if you go to a band concert or maybe an art show, you're going to see some differences there. But you want to have the true opinion of all high school families. Okay, the next example. A recent online poll posed the question, should female athletes be paid the same as men for the work that they do? And so here are yeses, but there are all yeses, nos, and then we have remaining that say they don't know. In spite of the large sample size for the survey, can we trust the result? So look at our yeses. So even though it says 44%, that's 13,000. No's say is 50%. It's 50% is 15,000 said no. The remaining, so almost 1,500, said don't know. In spite of the large sample size, we cannot trust this result. The people who feel strongly about this issue in both directions will be more likely to take this poll, which is a voluntary response sample. This will likely overestimate both the yes and the no responses and underestimate the true population opinion of don't know. See how they're really close and you have these don't knows? Well, it's voluntary, so they don't have to take it. Okay, that is it for these notes.